We are going to have a look at the equations of motion. Equations of motion. Now, the equations of motion gives the relation relationship between a few physical quantities like acceleration, displacement or distance, which is a scalar. Displacement is a vector. Velocity as well. All right. Now, if you talk about the average velocity, this can be given by the initial velocity plus the final velocity divide, we have 2 times here divided by 2. We use V to denote velocity. And for V, this will be initial velocity. And that will denote the final velocity. And this will be the initial velocity. Now, I hope you'll appreciate that we also have the definition of speed, which is, of course, a scalar quantity. And speed is the change in the distance change in time, and time is in seconds, distance meter or kilometers. We also have velocity, which is change in displacement, sake velocity here, change in displacement, change in time. This one is a vector, displacement is a vector, while distance is a scalar quantity. Now, I hope you'll appreciate that we also have a definition for acceleration. Acceleration is the rate of change of velocity. That will be V divided by T. Now, change in velocity is given by the final velocity minus the initial velocity divided by time. So we basically have, according to this, we basically have A for acceleration, so vector is equal to V final, V initial over T. If you multiply by T on both sides, therefore we have AT, which is equal to final minus initial. Let's go to a clean page here. We start, we have acceleration, which I emphasize is a vector quantity, multiply by T is final velocity minus initial velocity. So the final velocity can be given as VI, which is the initial velocity, plus AT. If I transpose VI, that side that's positive, then this constitutes your first equation, if not the second one, because let's call it equation A, for argument's sake. That can be the first one because we also have an equation here, or we have an equation there, with speed or velocity there. So we have, let's call it equation A. That is one of the, in some literatures, you have acceleration in initial velocity as U, and then in some literature is given as that. That's U stands for initial. We shall adopt that first notation. Now, going back to what we said, that the average velocity is changing distance over time. We say displacement, let's just write it once more. We said average velocity is equal to the change in the displacement over time, which we did in this previous page here. You can go, that's what we have here. Now, this will give us we say that this one stands for displacement by definition. So from here, we can say displacement delta x is equal to V. Now, the distance that a plane can take is just the product of the time that it takes and its average velocity. Now, don't forget that we had this equation here for an average velocity. That's for an average velocity. And that can be said, we agree that average is initial plus final divided by 2 divided by T is equal to changing displacement there. That's what we have. So Now, I hope you appreciate that that will constitute another equation. And then let's call that B. When that one we called A, this one we shall call B. Now, this you have to be careful that on equation A, the final velocity of an object is the sum of the velocity due to acceleration here and the initial velocity. Now, you can put units here, meter squared, meter per second squared, multiply by second, they'll give you meter per second. That's the unit for velocity, of course. But now when you come here, there's no acceleration. So you have to be careful that this is a constant velocity independent of acceleration. Now, so this can be written as S is equal to, you can write that as sometimes as said, you have that over 2 T in some literatures. Now, if we substitute equation A into B, we will have this here, which is S or delta X, displacement changing, will equal to, now we are going to say is initial velocity plus AT plus initial velocity over 2, close bracket, T. Now, we have just substituted for the final, which is this one here. This one here is the same as that one there. Now, wherever I see this one, this is the initial velocity plus the final velocity from A. That's what I have. If we add that up, you'll appreciate that I have 2 times the initial velocity plus AT, acceleration multiplied by time, all over 2, and that's my T outside there. The whole thing will become 2V over 2 times that T plus A over 2 T squared. T multiplied by T is T squared. Now, if you simplify this further, 2 will drop with the 2. This 2 will drop with the 2. You will have initial velocity multiplied by time plus half AT squared, and that will give you equation C. Now that is the third equation. I hope you appreciate that displacement here is given by the product of the initial velocity and time plus this, the product of half AT squared. Now that governs the given data as to which equation you can use. Let's have a look at the next thing that can take place. You have a few equations which let's see what happens. We said we had acceleration by definition, which was given by the final minus the initial over t. Let's call this 1. And you also have the distance, which is given by average velocity. Multiplied by time, which basically this is as is equal to Vt. Average velocity is that in the previous equation. Now, and then we call this 2. What happens when you substitute 1 into 2? You have S is equal to now you will have S is equal to U, or initial, plus final, which is of course the average velocity, and then your time here. From 1 here, we will have T is equal to V minus Vi over A. If you make T the subject of the formula, we'll have that. Now, for this T here, we will substitute that, which is Vf minus Vi over that. That's for that T there. Now, I hope you appreciate that on top here, I have a difference of 2 squares, which will give me the final, initial velocity. We have the final here squared minus the initial squared. This difference of 2 squares mathematically there. You can rearrange that, put F this side, put Vi that side, over 2A. Now, this is for S. We multiply both sides by 2A. The derivation there. And then you have, if you transpose that, this side first, 2AS will equal to the final velocity squared minus the initial velocity squared. So if I transpose the negative Vi squared becomes positive, I will have the square of the initial velocity plus 2AS, and that will result into my final V squared, and that you can call 3. So this brings us to the conclusion of how we derive the equations of motion. And in the next lecture, we are going to look at there are problems that involve the use of these equations. Thank you.